Same model, same prompt. Greedy mode, looping forever. Temperature 1.5, dissolving into fragments. In the next 6 minutes, the exact machine behind both. We rebuilt how ChatGPT thinks in runnable code and measured every step. Ask how ChatGPT works and you get metaphors. Autocomplete on steroids. A parrot. But the real questions are sharp. Why does it loop when certain? Why does high temperature produce nonsense fragments? Why does cutting one context word change the answer? None visible from the API. So we built the machine in miniature and ran it. The build, 5 Python files, a byte pair tokenizer learning its own merges, a trigram model producing real probability distributions, NumPy attention running actual softmax QK transpose over root D times V, a demo runner and 13 tests. No neural network, counting replaces learned weights on purpose so every mechanism stays visible. Where production models differ, we say exactly how. Step 1. Tokenization. The model never sees letters. 200 merge rules turn our sentence into 5 tokens. IDs 28, 44, 121, 28, 97. Decoding returns the exact string. This lookup is the model's only way to read. Production vocabularies are far larger. Example 50 to 100,000 symbols. Rare words split into fragments, which is why spelling is genuinely hard. Step 2. Prediction. After the context, the model scores every symbol, 225 of them. Token takes 64.2% of all probability mass. The output is not a word. It is a fresh distribution recomputed after every token. The other 224 candidates only exist through smoothing, the long tail. That tail is where strange text comes from, and we will sample from it later. Step 3. Attention. Softmax of QK transpose over root D times V. Every token scores every token, and each row sums to 1. Measured in this run, 36.9% of attention weight on related words against 11.1% uniform chance. Identical word forms locked on at 0.23. In trained transformers, these patterns are learned. This is how context gets weighed before prediction. Step 4. Sampling. Temperature rescales the distribution before the pick. Greedy loops. The model predicts the next token. The model predicts the. At 0.7, mostly coherent. At 1.5, the tail leaks out as fragments. And context is the only memory. Full context predicts explores at 47.3%. Cut the window to one word and it flips to controls at 36.5%. What leaves the window is gone. None of this is staged. 13 PyTest checks pass, round trips, probability validity, greedy equals argmax, seeded reproducibility, entropy ordering, attention row sums, and the context flip. Every number you saw came from metrics.json, written by the demo itself. Use it tomorrow. Repetition in your outputs? The spread collapsed. Raise temperature or add penalties. Strange fragments? The tail got sampled. Cool it down. Instructions ignored in a long chat? They scrolled out of the window. Restate them late. Structured extraction? Temperature 0. Brainstorming? Go warm. The model weighs everything in the window, so curated context beats maximal context. Takeaways. An LLM recomputes a full vocabulary distribution after every token. Attention is a weighted mixer. Nothing is fully ignored. Temperature shapes the spread. It adds no knowledge. Greedy means most likely, and it loops. Context is the whole working memory. Tokenize, weigh, predict, sample, append, repeat. Everything else is scale. Article and code link below. Subscribe to Byte Builders and stay ahead in AI.